Claire, thank you very much for that introduction. And Danielle, if you could put the slides up, that would be terrific. Um, Thanks for the invitation to speak today, particularly on this important topic, which I think is perhaps one of the defining challenges for our and future generations. So, Danielle, if you could put the slides up, that would be terrific. Thank you. So, as Liz has already outlined, the government has committed to net zero by 2050. But what you'll also be very aware of is that even if we do achieve that target, or when we achieve that target, we will still be subject to significant climate change. And therefore, as engineers, we need to think both in terms of what we can contribute to carbon reduction, but also be considering climate adaptation. And I'll be touching on both of those today. I wanted to start with a little bit of a story. 11 months ago, WSP committed to halve the carbon footprint of our advice and designs by 2030. And since then, I've had a lot of conversations with colleagues, I've taken informal polls of staff, and two clear patterns have emerged. And actually, these patterns have been similar to what I've seen outside of WSP as an organization. And the first part of that pattern is a really strong and positive enthusiasm about embracing this challenge. I regularly encounter that. But the second pattern is a lack of confidence about how to do that. So my plan today, my objective today is, Daniel, the slide doesn't seem to be advancing. I wonder if you might be able to do that for me. My objective today is not to provide a call to arms. My colleague Rachel Skinner did that brilliantly in her presidential address for the ICE. Actually, my plan today is to focus more on how. And having been active in this area for a while, it's clear to me that we absolutely don't have all of the answers, nor are there necessarily easy answers. But it's also very clear that we can't wait until we have those answers before we take some action. And for me, it's clear that we have to challenge and we need to adapt our thinking, which echoes very much what Liz was just saying. And this is what I intend to focus on today. So I'm going to do this in 5 parts. To start off with some background, talk about the quest for precision being the enemy of progress. I want to talk about carbon conscious design, ask that question, what do we design for? And then a few slides at the end around embedding change. So to start with that background, actually, like Liz, I think it's helpful to start with a little bit of personal background, particularly because it's often been asked to speak on other topics, but a little bit less on this one, although it is an area in which I've done quite a lot of work over the last decade or so. Perhaps dating back significantly to when I led the team that supported Highways England in developing their first climate change adaptation strategy and framework. Or the work that I've been doing as part of the evolution of the Eurocode, looking at how we embrace climate change within that suite of standards. Or more recently, leading the second work stream for the ICE's carbon project, engaging with colleagues in our carbon reduction efforts at WSP, and also through academic links, looking at research and academic collaborations. The other point I wanted to make in terms of background is I think it would be remiss of me to talk on this subject without recognizing the importance of taking a systems view. The importance of taking a systems view was recognized in the third work stream of the ICE carbon project. It's widely acknowledged. And whilst it's important that we look to optimize what we do within individual subsystems, we do have to be careful that we don't optimize a subsystem, but drive unintended consequences for other parts of the overall system. So that systems thinking perspective is clearly vital as we think particularly around carbon reduction. So now I want to move on and ask this question: can a quest for precision be the enemy of progress? Now, it was quite natural when as WSP, we set that target to say, well, the first thing we need to do if we're going to halve something is to understand precisely where we are today. How can you achieve that target unless we have that granularity of understanding? And that aligns very much with the sense of we can manage what we measure. And it aligns with the need to be able to benchmark and calculate the carbon consequences of what we do. But I think what I've seen in this area is a little bit of a risk as well, because carbon calculations, carbon benchmarking has a number of challenges, particularly going back to that systems thinking perspective I was talking about, where, say, a wholly asset-centric approach is inappropriate for transportation systems. But also, I think in terms of bridge engineering, one of the biggest contributions we can make is actually around life extension of existing assets and how that can be enabled. But how do we measure the carbon impacts of that kind of effort? It becomes a kind of carbon avoidance, and we know that we need to be really careful in how we think about carbon avoidance, because as people will have seen in the press, you can kind of get it very wrong, and so we have to think hard around that. So there are questions around this, and benchmarking is complicated. And I think what I observe is that sometimes we can spend a lot of effort, a lot of time thinking around how can we measure this with precision, and agonize over achieving that precision, perhaps not thinking what the bigger picture is, which is that we need to achieve change. And if we just focus on a particular point in time, how do we know which trajectory we're following, or even whether we're following the wrong trajectory? And that's why I think our efforts, and actually one of the positive consequences of setting a target and thinking hard about it, is that we do need to think about how do we accelerate change. And again, just to share with you within WSP, we've embraced a set of clear principles, following best practices in terms of how we do our carbon calculations. But in parallel with that, we're currently scoping 8 internally funded research and innovation projects where we're looking to collaborate with others to really accelerate change. Let me move on to the next topic I wanted to touch on, around enabling carbon conscious design. So I said that part of my focus today wanted to be in that territory of how. And I guess through my career, one of the things that I've seen change is the different consciousnesses that we bring to our design activities. So I guess there's always been cost consciousness, but I've seen increasing focus on consciousness around buildability, safety consciousness, maintainability consciousness, durability consciousness, the whole family of consciousnesses that we bring to our engineering activity. And I think where we need to get to is to be elevating that carbon consciousness. And I think a key part here, and the point around that idea of consciousnesses, is that if we wait until the end, if we design something and then we benchmark later, we've really lost the opportunity to have impact. That the point about cost consciousness is that we think about how can we design economically long before things go out to tender and we get prices back from contractors, for example. How do we elevate and bring that idea of carbon consciousness into our design and other bridge engineering activities? And there are some good frameworks for this. I've taken this image from the Green Construction Board's recent report, Good Progress but Not Fast Enough, when they looked at, they revisited 7 years on the infrastructure carbon review. And a very similar concepts of carbon hierarchy are included within PAS 2080, which many of you will no doubt be familiar with. But I think from a bridge engineering perspective, it starts to help us to understand what that consciousness might look like. And I think opens up some really exciting challenges for us. So at the bottom end, around building efficiently, how do we use less material? I think it's very interesting when we look through the history of civil and structural engineering that at times when materials were in short supply or were disproportionately expensive, and therefore material efficiency was a real drive, it actually led, I think, to some really exciting times in structural engineering, and often led to some very, very elegant and beautiful structures being designed because of this desire for material efficiency. So I think that's a really exciting challenge for us. Building smart, how do we use low carbon materials? How do we make sure that we are fulfilling our same objectives for particularly long life assets whilst reducing the carbon impacts of the materials that we're using? Or looking higher up the hierarchy, and clearly we need to go higher up the hierarchy to hit the overall targets. For me, as I've already touched on, one of the great challenges, the great opportunities here is how do we extend the life of our existing assets? How can we be smarter in the way that they are managed and maintained? How can we make sure that the untapped or reserves of capacity within the infrastructure that we have today are fully utilized? And I think from an engineering point of view, I know in my career, trying to explore some of those questions has been some of the most fascinating technical work that I've ever done. I think what we're also looking to do is to try and demystify some of this. We know that we've all seen these. When you buy a washing machine or a house, they come with a energy efficiency rating, a very simple device that enables us to get a very rapid understanding of the energy efficiency consequences of different things that we might use. And I guess what we're exploring at WSP is asking to say, well, can we do something similar around the carbon consequences of the materials we might use or approaches we might use? How do we make this simple so that at a concept design stage, at that point when a lot of the really important decisions get baked into a project, how can we bring, as I've alluded to, that carbon consciousness readily to design at the earliest stages? Well, let me move on then, and I've touched particularly so far around carbon reduction, and I want to turn now towards the direction of climate adaptation, and actually this builds really nicely on what Liz was saying. And Liz has talked about change and disruptive change, but also the mega trends that we are seeing, and one of the things that we ask all of our people to do within WSP at the start of a project is to pause for a minute and to think about whether what we are embarking upon is what we call future ready. And that simply means to think about those trends, to think about what we're doing, and to say, is what we are looking at not only suitable today, but will also be suitable for the future? And there we're thinking exactly as Liz has said, around those trends around demographics, the trends around climate, the trends around resources, the trends around technology. And what that opens up, I think, is some really interesting opportunity to ask that question, what do we actually design for? And some of those trends are kind of clear in terms of their direction of travel, but the degree to which changes will happen, there's obviously some uncertainty, and particularly uncertainty when we're thinking in terms of long life assets like bridges. So how do we start thinking differently about design, particularly in an environment where the functional demands upon what we are looking at over their life is going to change? We've tended in the past to think around stationarity of climate, for example, and we know in the future that's not something that we can rely upon. So how do we tackle this? And here are just 4 different ways of thinking about it in terms of that question, what do we design for? Do we just design for new defined provisions? And I'll come on later when I talk briefly about the Eurocodes and evolution of the Eurocodes for what we're seeking to do there in terms of new defined provisions. But I think there are also some really exciting alternatives. What about design for adaptability? So we don't know exactly what a change might be, but we know there's something we might want to do in the future. Why not create that adaptability in what we design from the outset? Or design for resilience, where our asset performance is insensitive to change. That's something as bridge engineers we kind of understand because we're used to thinking about robustness. Unplanned or uncertain things might happen, but we know that structures' resilience to that change, robustness to that change, is influenced by things like providing continuity within the structure or ductility of elements. These things can be significantly beneficial in terms of the sensitivity or insensitivity of assets to change. Or the 4th one, which I think is conceptually really interesting, where we design to make sure that what we build or what we manage, what we maintain, is at least achieves a certain level of safety, serviceability, robustness, and durability. We set a minimum level. But it's kind of inherent in the way we work that actually what we build will always be better than that. And sometimes it's quite hard to quantify how much better, But actually, if we build in measurement into what we build, then we have the opportunity to understand what is that gap between what we've built and what we need. And if we understand that better, then we have the opportunity to extend the life or increase the demand that we place on assets without compromising their safety, serviceability, durability, or robustness. And I think bringing in some of these different mindsets potentially helps us to get away from what might be a vicious circle in terms of worrying about change and then over designing and then potentially using increasing carbon quantities, for example, versus that virtuous circle, which is the one that we want to be on. So then let me wrap up and talk a little bit around embedding change. So again, Liz talked around the need for skills within the industry. I've talked about how we need to equip ourselves as engineers to bring that carbon consciousness to the work that we do. But we do also operate within a framework, a system. We work under contracts. Those are procured in a certain way. Regulations exist. There are standards. You know, one of the bits of feedback from some of the ICE work and some survey that was undertaken was that people feel inhibited sometimes by that framework within which we operate. So under the ICE Carbon Project, in that section around regulations and standards and contracts that I've been looking at, there are some emerging recommendations that are coming out of that. You know, one, that government needs to advance a system of regulation to drive carbon reduction. And we've set out some specific thoughts in this domain, particularly recognizing that for infrastructure, any such targets, any such regulation is likely to need to have a component of being systems-based rather than asset-based, which might work, could potentially work in the property sector. But we've also made a series of recommendations in the standards domain as well. And just to pull out a couple of these. So firstly, the standards developers do need to introduce a process of carbon impact assessment for new or revised standards. You know, and it's great that Highways England, and I'm sure others will follow soon, and may already be partway down the track, have introduced just that kind of process into the way in which changes to standards are reviewed. But also importantly, there is a need for proactive action here. Again, second recommendation here, about removing barriers to efficient material usage, but probably more important, the usage of low carbon or recycled materials. So those are some of those recommendations or emerging recommendations from the ICE Carbon Project. And I'm just going to wrap up by just mentioning a little bit around Eurocode's evolution. So as many of you will no doubt be aware, we're currently engaged in a massive project to develop the second generation of the Eurocodes. And I guess I'm responsible for leading that in my role as chairing the overall committee NCE 250. And one of the requirements of the mandate that we received from the European Commission for this work was to think about climate change and how do we take account of climate change within the evolution of the Eurocodes. And clearly, one of the key factors there is what do we do in relation to environmental actions, so principally wind, snow, and thermal actions. So you'll understand, I'm sure, everyone will understand that in terms of the magnitude of those actions, those are included within national annexes. So the magnitude of the actions are included within national annexes, but the Eurocodes themselves provide the framework, the template within which you use those specific values. And so where we're heading with the Eurocodes on this, and this is still in draft and it needs to go through the processes of inquiry and formal vote, but has a good level of support from the 34 countries engaged in Eurocode development, is that we retain essentially the current model where we have the wind map, snow map, thermal maps within national annexes, but we also give national annexes the opportunity to introduce a scaling factor that can be applied to those values to take account of climate change, and also to provide that flexibility to go beyond that if a client wanted to do that on a project-specific basis. And for wind and for snow, then it works to have a scaling factor which is a multiplier. When we look at temperature, then that scaling factor needs to be a delta. And there is research underway to look at how these scaling factors might be derived, and it's not straightforward. There is complexity here. But there's been some really positive engagement with the European Commission Mandate 526 team that I've been engaging with, or with the Copernicus Climate Science Service, who asked me to speak at their General Assembly around what we're seeking to do. Because actually where we need to get to is that integration of thinking around structural reliability and climate science, so that we can then help national standards bodies to develop the parameters to put into their national annexes. So let me finish there. I hope that that's been interesting, and thank you very much for your attention today.